All right, so once again, good morning. It's about 10:05, so hopefully everybody got in that needs to be in. For whoever did not log in time or wasn't able to come and they registered, this slideshow will be shared. We're also going to upload it onto our YouTube and link it all over the place. So essentially what we're going to be talking about is the newest VFD we have, which is the H100 Plus, and primarily it's a large firmware update. A lot of the features on this new firmware are pump focus, so we kind of present this as a pump solution drive. And then you'll see towards the end of the slideshow that we could do a lot more than pumps with the H100 Plus VFD. So this is a little bit of what we're going to go through, where we're going to talk, of course, a lot about the pump firmware. We have a little bit of a history lesson and a company introduction on LS Electric. We'll go through the hardware specifications, which are very similar to the H100, except some little new things on there, which are going to be advantageous. We'll talk about the new pump features. And then we're also going to kind of compare that to what we have on the existing H100 drive, which you guys may be familiar with. I'll also present the HMI solution that we have for pumps. So we do have like a kind of a turnkey HMI program that you could load into an HMI and use that as like a programming tool. And then we'll finish off with, kind of technical support, technical services, what we could offer as far as supporting this new product. And then just a second, I'm going to let a few more people in because I hear my computer beeping. So we'll let these few people in. All right, so back to the slides here. So some of you guys may hear this every time we come by your office and, give a presentation. But as you may or may not know, LS is sort of a spinoff of LG. LG is a large Korean conglomerate, and it got split up into three different companies. So we essentially got too large. So we're part of LS Group. We're LS Electric, and then even more particular than that, we're LS Electric America, which handles North America. LS Group as a whole has about 13,000 employees. Here's our, sales values. We have about 3,500 employees. And our office here in the U.S. is ever growing. We probably have like maybe 40 or 50 people. I haven't counted, but we've grown a lot over the years since I've been here. So we consider ourselves one of the pioneers for electrical power systems, automation, and green energy. We're not going to talk about all of our products, but if you look on our website, you'll see a ton of them. We have a lot of DC components, DC switches, DC circuit breakers for renewables. We have PLCs, HMIs, servo products. So what we're going to focus on today, though, is going to be our VFDs. This is just showing kind of like our global support and kind of what we offer across the world. If you look on the right, you're going to see our offices that, you guys may call on us for. So we say we're out of Chicago. We're actually out of the Chicago suburbs. We have ESS out of Charlotte, and then we have another office out west in Irvine. This is a little bit of the history of LS, so we've been around a while. Some of you guys may have heard of LG and LG Industrial Systems. Then we changed our name to LS Industrial Systems. And then a few years back, we actually rebranded to LS Electric. So that's why you may hear, LG, LGIS, LSIS, LS Electric. It's all kind of one and the same. So here we're kind of getting involved with actually the main topic here, which is the H100 Plus. So as I mentioned, the H100 Plus is primarily a large firmware upgrade. So we have improved process control. We have the built-in lead lag capability. We'll talk a little bit further about that in a couple slides. We have PI auxiliary control, where we could do suction detection, level detection, vacuum detection, in addition to the primary PID loop. We could do flow monitoring, differential level control, and detection. We also have the improved keypad, so some modification to the HOA and how it works, in addition to a power on run function. The PID control has been enhanced. So in the past, we've had problems where we could really crank up the gain, decrease the integral time, and it's still, not responsive enough for some applications. So we've improved the PID loop. In addition, there's a PID input limit, a integral limit, PID excel time. We simplified the PID group. So these are things we're going to mention. We have individual slides on it, such as no flow control, pump over cycling, high-low feedback detection. So some of this you may say, okay, you know exactly what that is, and that's good. We'll also go through some slides here and show you show you a little bit more details about it if you're not familiar with it. So here's the standard functions on the right are the standard H100 functions, and then the new functions are on the left. So stuff we had up till now on the standard H100 drive are soft fill operation, which is commonly used in irrigation. We have long pipe length that you need to slowly fill before regulating a standard PID loop. The scheduling with the real-time clock, flow compensation, maybe you're going uphill or you got to compensate for, pipe length, power on resume, sleep boost, lubrication control, damper control, preheat, level detection, just to name a few. And then, as I mentioned on the left, these are all new things on the H100 Plus VFD. So one of the really nice ones is no flow control. So we could actually detect a no flow condition. So somebody shuts off a valve, we're deadheading the pump. We could detect that and put the drive to sleep. We have the flow monitoring. We have the PI auxiliary control, the pump over cycling protection, minimum pump speed, thrust bearing control. The lead lag, as I mentioned on the past slide, the enhanced PID, and backspin timer. So the only thing we got rid of is some of the functions that we feel people really never used or they never asked about, and that was the external PID control. Not many people use that. We called that the ePID function. The payback counter, that was the function where you'd program in your kilowatt per hour, and then it would calculate, payback on the drive. Not many people utilize that. And then we also got rid of the M2, the Motor 2 group, key customers in the pumping industry, and this is the feedback we got. Towards the end of these slides, too, you'll see a little bit of a competitive comparison of how we stack up. So here's the main specifications for the H100, and we're kind of talking hardware features and ratings. So these are just wall-mounted drives. Just like all of our other drives, they're going to be, IP20 rated for the most part. You could buy conduit kits for these all the way up to 800 horsepower. All the boards are conformal coded to 3C2 class. We, as far as communications, we have built-in Modbus RTU, which is the same for all of our drives across the board. That's the native protocol. We also have BACnet MSTP, so the serial BACnet, Metasys N2, and then LS bus. And if you need something different, you'll see below that on the bottom left here, we have a LonWorks card, which is an option, Ethernet IP card, Modbus TCP card, which is the same. Same as the Rapinet card, or we could do a BACnet IP card. So if you guys have price sheets, catalogs, stuff like that, you should be able to see those available options. So yeah, just kind of know that going forward, what we offer on this drive. So in the past, the H100 drive was a normal duty only drive, so it would have 110, 120% overload for 60 seconds. Something new on the H100 Plus is it's actually dual rated. So we still default to the normal duty rating. So we default to like more of a fan and pump kind of application setting for the duty. You could flip that parameter over and you could get 150% overload out of this VFD. Not to say it's like an industrial drive, but there is some industrial applications that we could run with the H100 Plus. So as of now, the specifications are very similar as far as like the current and horsepower range on the H100 Plus as the H100. We go up to 120, we up to 25 horsepower, 230 volt, which is kind of a limiting factor. So later on this year, we're planning on releasing up to 125 horsepower, 230 volt drives for the H100 Plus. We still have 1 horsepower up to 800 horsepower for 480 volt. And then for the Canadian market or wherever you may be running 575, 600 volt, we're releasing that voltage class towards the end of the year, 7.5 up to 125 horsepower. So these are all the normal duty ratings we're giving you here. If you change the parameter to heavy duty, the overload capacities change a little bit and the horsepower rating changes as well with that. So here we're listing the input voltage ranges, which are pretty standard. I don't think we need to go through that. This drive currently is a V by F control method, so volts per frequency. Output frequency is 400 hertz. maximum, pretty standard. This is the protection degree, IP20, IP00 on the larger ones, and then you could purchase a conduit kit for any capacity that you may be running. Additional options in addition to the communication options are extension I/O. We have the flange mounting, the heatsink out the back kit, and then of course we have a ton of compliances. Most of you guys on this webinar probably care about UL, maybe some CUL for the Canadian market. We also have, CE, IEC, all kinds of marine standards, seismic ratings, plenum ratings. So we should have most certifications and standards that you need. So if you need any kind of paperwork or documentation, you can always shoot us an email on that. All right, so getting down in some of the functions here. So lead lag control is a common feature that people ask about. And this used to be a kind of a custom firmware request on the H100, but on the H100 Plus, it's built in, and I feel we made it really nice because we actually made a macro. So what the macros are on the H100 Plus is when you first power up the VFD, you're going to see easy start, which is like a quick start menu. And if you hit yes to start the easy start, it's going to ask, are you doing a pressure control setup? So a PID loop, you could say PID, you could say lead lag, or you could just say basic. And then it's going to set up a bunch of parameters for you, and it's going to give you a kind of a question and answer list, and you'll answer all the questions, and you'll be 90% where you need for a given application. So for lead lag, we have a few different modes. We have a contactor lag mode. So this is kind of a more simple lead lag where you have one VFD and you could have up to 5 auxiliary motors. So one motor or pump is going to be variable speed off of the drive's UVW motor output terminals. And then you could have up to 5, like running off of contactors or soft starters or some kind of sequence like that, some kind of motor starter. So lead lag in general is if the first pump can't keep up, it's going to start staging other pumps, and then as we meet demand, it's going to start destaging. Okay, and similarly, we could also do the smarter lead lag or multiplexing, and what that's going to do is it's going to run multiple drives. So I think our next slide shows that. We could do this up to 8 VFDs. So this is just like a standard lead lag. In this picture, we're showing you 5 VFDs. So if the first drive can't keep up, the second one comes on, then the third, and so on. We could also set up, other functions. Most commonly, people are doing alternation. So you might want to alternate every 24 hours, to minimize pump wear and prevent, the first one from running, forever. Other things we could do is we could do a FILO or a FIFO. So that's a first in, last out, and a first in, first out. So that's just the order in which the pumps are coming on and off. We could also do a fixed lag operation, and I believe we have another slide that shows this visually. We could do a follow the lead situation. We could do a jockey pump. We could do interlocking, which kind of enables and disables the pump, lets it be available on the network or not. And then, as we mentioned, we could also do the alternation. We're going to kind of dive further in right now. So here's a little bit more further information, kind of more technical on the lead lag. So here we're showing you on the left the fixed lag on the top, and then the follow the lead. And without zooming in and, kind of going through all this, the top picture right here is running a fixed lag. So that means you could be running your main lead drive, 0 to 60 hertz, based on your PID loop, your feedback, and your set point. And then the lag drive is going to be running at a fixed speed that you predetermined. So you could, for example, set the lag drive to run 55 hertz, and it's just going to be on off 55 hertz, or just be sleeping if it's not required. Whereas follow the lead is exactly as it sounds. It's going to match the speeds of the lead drive to the lag drive. So they'll both be ramping up and ramping down and trying to load share. We also have the lead lag alternation, as we mentioned on the previous slide. So the first in, first out, first in, last out, or you could do it based on operation time. So I think first in, first out, and first in, last out are pretty self-explanatory. Operation time order is the drives are actually going to calculate the time of the least operated pump, and it's going to make that one run first. So if you have 3 pumps on a triplex, first one's running 10 hours, the second one's 15 hours, and the third one was 3 hours, the third one's going to come on next, to try to get up to the same operation time as the other 2. So again, it's just a way to, share the load and prevent, pump wear from happening just on one pump. We could also do a jockey pump operation. So this is related to lead lag. So if you imagine they're showing you here, motor 1, 2, 3, you could set one of those pumps to be a jockey, and it's like a pressure maintenance pump. So if you have like a 10 horsepower pump and then two 50 horsepower pumps, you may want to pull on the 10 horsepower first, for low demand situations. And if the 10 horsepower can't keep up, then it's going to start staging larger booster pumps like the 250 horsepowers, for example. This is one of my favorite features, as nerdy as that sounds. I do have a favorite feature on the H100 Plus, which is no flow control. So in the past on the standard H100, sometimes we run into situations where somebody would shut off a valve and the PID loop wouldn't respond in time. So the pump would deadhead and it would take a very long time, if ever, to go to sleep. So no flow control is the solution for that. So what it's going to do is it's going to check out this no flow control trigger bandwidth, and it's going to compare that to your set point. And this red line right here is your output frequency. So if we're outside of that bandwidth, that trigger bandwidth for a given time, so there's a delayed time for this no flow control, then we're going to activate the no flow control function, and we're going to put the drive to sleep. So no flow control is essentially a way to detect the shutting off of a valve, a deadhead situation, and it's a way to put the drive to sleep. So we've used this a few times, and it's worked out really well. This is another new feature on the H100 Plus, which is the flow monitoring function. So a lot of applications, I find, especially out west where they're pumping a lot, large irrigation applications, you may be pumping off of like some kind of public reservoir, aquifer, a stream, or a river. A lot of times the states are going to regulate how much you could pump, at a given time. So you're going to get a flow meter and you're going to apply it to your drive. And some of the things we could do with that is we could display the flow rate and monitor it based on the meter. And as far as electrically speaking, we could run a pulse train input type flow meter, or we could use like a analog input flow meter. We could take that data, we could trigger a digital output, we could stop the drive, we could give you a warning, we could have a high flow rate trigger or a low flow rate trigger. So this is all related to that flow monitoring or the flow meter. We could also have an accumulator, so we could hit a maximum flow amount, and then based on when we hit that accumulation, we could trigger an output, a warning, or a trip. Additionally, we could use the flow to go to sleep. So we could have a low flow situation or a no flow situation, and then we could shut the drive off. And then, as we mentioned, we do have a high and low flow rate limit. So we could trigger, something to happen then, and we could actually run our PID operation, off of the flow as well. So in this little diagram right here, we could run two transducers. So we're showing you a pressure feedback transducer in addition to a flow feedback transducer. And based on the levels of these two different transducers, we could switch between flow control and pressure control. So most commonly, pressure control is our primary feedback loop, and then flow or suction or something like that would be our secondary feedback loop. All right, so this is kind of a spin-off of that flow control because we're talking about PID auxiliary control. We're running a couple different pressure transducers or maybe a suction transducer with a level transducer or pressure transducer. So PI auxiliary control allows the drive to control pressure primarily, as long as your auxiliary level is satisfied. So if you think of like this middle guy here, water level control, you have a tank or an aquifer, like a downhole, transducer. And if the level gets too low, we're going to monitor the level and worry about the level until the level comes back up, and then we'll switch back over to pressure control. Similarly, we could do the same thing for suction. If we ever have a low suction and lose suction on the inlet, we probably won't be able to achieve pressure on the output. So we're going to put you to sleep, until we could start back up. And similarly, we could do the same thing with, a vacuum control. So these three things we're talking about here involve two different transducers. And here's an example on the bottom right here. We're saying if your auxiliary set point is greater than or equal to the sleep level, that changes what PID we follow in the VFD. Additional features, and this is just kind of standard, you're running one transducer, maybe a single PID loop, nothing auxiliary. We have the pump over cycle protection, And so there's a quite detailed drawing down here. Essentially, all this is showing is you don't want to go to sleep and wake up too many times because that's going to wear the pump down. So you could, this is all programmable, all these little AP2s. If you're not familiar with the keypad, the AP2 is a parameter group and it's customizable. You could set it to do a warning, you could set it to do a trip, you could set the time, and then you could also set how many cycles you want to hit before you stop the drive. So you're kind of customizing your overcycle level. Another nice thing on the right here, we do have independent low and high feedback detection levels. So you could set like a 150% or 150 PSI high limit, a 10 PSI low limit. Each one of those has their own delay time associated with it. So if you could run a little bit longer at a low feedback versus high feedback. So it's all, totally customizable. So moving on here with some other new features, and all these new features are only on the H100 Plus, just a reminder for those of you guys that popped in now. We also have the set point timeout. So this is like a function when you can't maintain the set point. So something is seriously wrong if you can't maintain the set point. So either somebody opened up a valve that they shouldn't have, there's a broken pipe condition, there's a blockage in the impeller. So you're running up to speed and you can't make your 60 psi, your 70 psi, whatever your program set point is. We could assume there's an issue, and instead of just blasting water all over and consuming power from running the motor, we'll actually shut you off. So that's what this set point timeout function is. We also have the differential level control. So this is another function that's similar to the auxiliary PID, but it's used in a different way. So you're going to have two pressure transducers running back to the drive. So they're both going to be on the outlet of your pump, as we're showing you in this picture here. But one's going to be before some kind of filter or mesh screen, and the other one's going to be after. So if we see a certain difference, as we mentioned here, a differential between the two, we could assume that this filter is clogged or the mesh screen is clogged. So this is good if you're pulling off of like a river. A lot of times you get like seaweed, some kind of debris in there. So this is a way to trigger like a digital output, a warning, or just stop the drive, if there's some kind of blockage. So you could also use this for like a back flushing operation. On the H100 standard drive, we used to only be able to go to sleep based on frequency. We got a lot of requests, and we came out with a lot of like customized firmware to go to sleep based on current or go to sleep based on a feedback value or a flow rate. So now we've taken all those customized firmwares and we put them standard on the H100 Plus. So now you have a parameter that says what kind of sleep level do you want to do. I think most of the time people are still going to go to sleep based on frequency, but we've done, some applications where, we'll have somebody that wants to go to sleep based on, PID feedback. So look at the feedback level. If the feedback level is a certain value, go to sleep. Or if you have a flow meter, we could also go to sleep based on your flow rate. So you got some flexibility there. Additionally, we also made the wake up level a little bit more flexible as well. On the H100, I believe it was just like a deviation. So it'd be a deviation from your set point. So for example, if your set point was 60 and your deviation is 10, we drop to 50 PSI and the drive wakes up. Works most of the time, but some people would want like an absolute value. So an absolute value is going to be a fixed level no matter what your set point is. So that's something that's now selectable on the H100 Plus VFD. Additionally, we've modified the sleep activate level to give you some more flexibility as well. So you could, this is kind of a little bit of a long table here, but you can see you go to this parameter, your sleep level type, and then you could go ahead and select like frequency, yes or no, or whatever kind of level you want to do. And that's going to change how the sleep level is activated. Additionally, this one has been requested for some submersible pump applications or sometimes pivot applications where they want the sleep to be off. And so what that means is it's going to go to sleep, after it meets the sleep criteria that you set on the left here, and the drive is not going to be able to wake up until you kind of manually tell it to wake up. So you run your pivot and then it shuts off. Okay, so that's an example of when you'd use that. Additionally, just overall stability for PID, we have these three functions we're listing on the left right here. We have the PID XL decel time, and this isn't really an XL decel for your PID loop. More so, it's a XL decel for if you're going to change your set point a lot. So sometimes we may have somebody that's using like a speed pot to adjust their set point. So if you turn your speed pot all the way up or all the way down rapidly, that could cause some instability in your PID loop. So this is actually an XL decel ramp for your set point. So it's kind of a way to help, prevent hunting, when you're rapidly changing, the set point for the PID loop. We also have the PID input limit. So this is actually going to limit the input of the PID controller. And then we also have an integral limit. So the PID stands for proportional integral derivative. Most of the time in pumping, we don't mess with the derivative. So you may hear people call it just a PI loop. So we have our P gain and we have our I time. So the integral limit is going to limit the amount of error that we could accumulate. So if we could eliminate the amount of error, that's going to prevent integral windup, where you could also overshoot or have sluggish operation. So the combination of these three is meant to improve the responsiveness of your PID loop. We also have the backspin timer. So this is a great function for vertical turbine applications. So this is going to prevent pump damage. So with a vertical turbine, you're going to have, your water flow that's, being pulled up. And if you ever stop or trip or remove your run command, that water column is going to fall back on the pump, which could spin it backwards. And if we start a backward spinning pump, there's potential for tripping out on the drive, causing mechanical issues and damage. So a backspin timer, simply put, is just a timer that's going to stop you from running again. So you could set this for, I think, some crazy time, like 10 minutes or something like that, depending on how long it takes for that water column to fall down. And if you try to give it a run command, as we're showing you here, it's not going to let the VFD start until that backspin timer expires. And that's based on whatever you program in the drive. As we mentioned earlier on the brief introduction, we did modify the handoff auto a little bit. So one of the common questions we'll get is, you give the drive a run command on P1, but it doesn't start because then you got to press the auto key. So one of the new functions we put on there is you don't have to press the auto key. You just give it a run command. So we're saying an FX input, a forward run input, and it jumps right from off past auto mode and into run. So it automatically puts you in the auto mode. So that's a nice feature, especially for pumps, irrigation, more remote and rural applications. Is nobody wants to press any keypad; they want things to start all the time. Additionally, one of the other things we added is we could do a hand operation by a digital input. On the H100 standard, you used to have to press the hand key. Now we could automatically switch to hand. If you have some kind of remote sequence, you could program a digital input. We also added the off-key enable function. So these are these new parameters down here. So we used to default to lock the keypad out. Now we have it set to an off-key enable. So that means you can press off even if you're in auto, and it'll just stop. So you used to have to drop your run command, which could be a remote signal. We could also disable the hand key. This is like a common safety request: is somebody sees a green button, but if you press hand, you're just gonna not run your PID loop. So you could run 60 hertz, you could start blowing out pipes, overpressuring, stuff like that. So the advantage of disabling the hand key is, you're not letting somebody kind of bypass everything you set up for your PID loop. Couple other things that we, improved on the keypad is a keypad power on run function. So it used to be if you had a DRV6 set to keypad, you'd press your auto key twice to start the drive, and you wouldn't have any remote run signal. You'd just be running off of the keypad, so kind of like a local control, if you want to describe it as that. But the problem is if you ever lose power, well, you got to press the auto key again. So some applications don't have any run signal. They just want to run off of the keypad, and if it's running off the keypad, you lose power and you come back on, it should remember that. So this keypad power on run is exactly that function. It's going to remember that you were in auto. After a power loss, no matter how long, it's going to go back into auto again. So it's going to go back to the normal operation that you would expect it to. So this is a new parameter function as well. Additionally, the off key used to be the reset key. So you ever trip out on anything, the off key is gonna reset the drive or reset the trip. Now we actually made the multi-key, multi/reset key. So you have two different ways to reset the drive. Some people just ignore all that and they just, cycle power. That always works as well. So multiple ways to reset, a trip. We also have the hard current limit. So the current limit is just exactly as it sounds. It's going to limit the amount of output current, and it's kind of like a foldback function. So we'll reduce your speed all the way down to your minimum pump speed if we need to limit the current. So you go in there, you program a current limit, you enable all your functions, and as we're showing you right here, as your current goes up past your limit, your speed's going to go down. So theoretically, if we reduce our speed, we're reducing the load on a variable torque load, such as a fan or a pump. So it's just a way to prevent tripping out, essentially. This is a common request and a common requirement in most pump applications. Minimum pump speed, it's pretty standard. I believe we had this also on the H100. We might have modified it a little bit. We actually have 3 different minimum pump speeds, and whatever one is the highest of the 3, that's going to be your minimum. So we have a thrust frequency. So a thrust frequency is commonly used on submersible pumps. So typically you got a ramp from 0 to 30 hertz in 1 second just to lubricate the thrust bearing on a submersible pump. Then we have our just generic minimum pump speed, and then we also have our frequency lower limit. So this ADV25 is a parameter that's on all of our drives, M100, G100, all of them, whether it's industrial or commercial or fan and pump. So if you set up all 3 of these, remember whatever is the highest of these is your new lower limit. So hopefully that makes sense. This is a nice feature as well. On the left here, this is the existing PID group, and it goes from 1, or actually 0, all the way to 95. So there's quite a few parameters there in the PID group. So even myself, I would get lost in the PID group wondering what half of it does. So we've actually simplified it on the H100 Plus, and we only give you, these 15 or so parameters. So we kind of made the advanced group a more basic, user-friendly level. You could go back and open up all the parameters if you need. We've done a lot of startups on the H100 Plus, and the basic level is more than fine. So it's just a way to simplify the PID group, okay? So you could go up and down, you could go through this group, and it should have everything you need. I don't know if you guys could see it on the video, but you got like your set point, your feedback, your P gain, your I time, your levels, your units, your sleep, your wake up, all the basic stuff like that is in this basic PID group. So it should be pretty user-friendly. We also added a kind of generic pump trip. So if you trip out on high feedback, low feedback, the set point timeout, the overcycle, all the things we talked about a few minutes ago, we could have a digital output close for a pump trip. So if you only care about pump codes and pump faults, you could program a digital output for that. We also added a loss of prime display. So in the past, we used to use like an underload detection to simulate, losing your water. Now we have a loss of prime. So a little bit more user-friendly, some nice pump jargon for the pump guys. All right, so we're going to finish off with some of the existing functions that you may or may not be aware of. And so when we say existing functions, we're talking about the H100. So we still do have some H100s in stock. I think maybe, I don't know, throw out a number, maybe 90% of it's been replaced by the H100 Plus. So you guys will start seeing the H100 Pluses on your deliveries and stuff. Real-time clock, or RTC. So the H100 and H100 Plus are the only VFD we currently offer that has the battery built in there. The trick with the battery is you got to remove the cover, slide out the little plastic slip like a toy car, and then that enables the clock. Otherwise, you could set your clock, and as soon as you cycle power, you're going to lose your time, and you're going to set it again. So some of the advantages with the real-time clock is you could do scheduling. We have like a bunch of different operations. You could say run PID on these days, run a fixed speed on these days. So you could do some scheduling. One of the key advantages, we store the 5 most recent trips on the drive's keypad, and we'll actually timestamp the trips. So that's what most people use the real-time clock for, is just to kind of figure out when the drive tripped out, when there's nobody around. We still do have like the underload protection and the load tune. So the load tune is tuning the drive to match the pump curve. So it's going to run at 2 fixed speeds, and it's going to calculate the amount of current between those two speeds, and it's going to make a pump curve. And if you ever fall above or below that pump curve, we're going to activate like an underload protection or an overload protection. Uh, Similarly, we have our flow compensation. So if you have longer pipe length, you're going to get some pressure loss, from the start of the pipe all the way to the end. So this is kind of just like a gain. That's what the flow compensation function is. Pump clean, or commonly called like a deragging or an anti-jam. This is going to run the pump in a forward and reverse direction. It's going to oscillate between the two based on how you set up the profile to get any kind of solids or anything that's jammed up in the pump out of there. So this will run backwards if you allow the pump to run backwards. So some pumps, have anti-reversing ratchets on it. That's not going to work very well. So it's only going to run forward in those situations. So this may be common, in wastewater and stuff like that. We also have our decel valve ramp. This is more existing functions on the H100. So this is a separate XL decel time just to prevent water hammering if you have a check valve on your line. Lubrication is a very simple relay output you could program. So whenever you give the driver run command, you're going to pre-lube your system if you need to. And then after you finish your pre-lube function, it's going to start cranking up your output frequency, as we show you right here. We still have our pipe break detection, which is a great feature. A lot of times people aren't monitoring, these systems, especially, middle of a field. So we could trigger a pipe break detection when your feedback drops low and your speed is high. So if you're running 60 hertz and you're way off from your set point versus your feedback, we could assume something's wrong. So it's going to trip out on a pipe break detection. So these are all functions that you could add, after you do your initial PID loop setup. We have the level detection. So if you want to see if there's any kind of abnormal situation, like a clog in a filter, damage within the impeller, stuff like that, we do have like a generic level detection you could program. And this is in addition to all the high feedback, low feedback, flow levels, and stuff like that. So should have plenty of different level detections that you could enable. Okay, so that was it for all the features that are existing and all the new features on the H100 Plus. So we're getting towards the end here, and this is our HMIs. So you may or may not know that we do have HMI touchscreens from 4.3 inch all the way up to 15 inches. We have a program, which is the screenshot right here, which is our H100 Plus pump program. So we could share that with you. You could load that program into an HMI, and you could use this as a programming tool. So you could actually plug this HMI into the keypad port. All of your parameters are going to come up on the HMI. You got your handoff auto keys right there. So this kind of replaces the keypad. You could do it permanently. You could do it temporarily. You could just use it as a programming tool. It's up to you. Or you could just use the built-in keypad. And I guess the third option would be you could actually use the drive wizard function. So I don't know if we have a slide on that, maybe not. But we also do have our DriveView 9 software, which you could purchase a cable from us, for a few dollars, and you could plug into the keypad port as well. So there's a few different ways that you could program this, whatever you prefer. We should have an option for you. So here's a little bit of a competitive comparison to us and somebody we tend to run into a lot, which is the IQ pump. And you'll see we're also comparing this to the H100. So the H100 didn't have a lot of these new features. So that's the whole reason why we came out with the H100 Plus and why we're presenting it to you. But I think if you look at these key functions that a lot of customers use and compare it to some of the competition, we pretty much match it. So as far as lead lag, I mentioned that's built in. Suction and level control, that's standard. Flow monitoring, differential level control. I think you should see that we pretty much, meet all the requirements and have the same features. And then on the bottom here, as long as it's not cut off, some of the advantages to us is we have that simplified PID group where you can do things, just with the 15 parameters. We also have the built-in macros. I do a lot of training classes, and whenever we do PID, I make people do it the hard way, and then I make them do it the easy way. And the easy way is the macro, And then, after they do the macro, they're, really happy that, they could just do a pump startup within a few minutes. I'm also told a lot that our keypad is very intuitive. We have our 12 different parameter groups. Most of the time you're in 2 or 3 parameter groups. You could hit up or down and pretty much find what you need. Additionally, when you set up the pump macros, it's going to list out, the 20 parameters you need. So you could just do everything through your macro group. So programming, commissioning, and all that is, I think, one of our key advantages. I think the drive is very easy to program. So here's just some retrofits and some references. So we've done more than these. I think I have 3 examples here. These are just 3 local examples that I personally helped out with. So the H100 Plus has kind of been like a soft release. So now, as I mentioned, I think most of our stock should be H100 Plus, but we've gradually been getting in H100 Plus recently. And some of you guys have been using H100 Plus for maybe the better part of a year. So on a custom request, we've been upgrading VFDs, based on customers, requirements if they need a certain feature. So in this one, this was a lead lag opportunity. So they were actually running Danfoss, and this was like I think this was like a high-rise condominium building in Chicago. Danfoss never really met the customer's requirements. They could never get the lead lag and the alternation working. I think this one was alternating every three or 4 days, and the Danfoss would never do it. So they literally ripped out the Danfoss, and we swapped in the H100 Plus, and this is actually the Danfoss box here. So we actually used their circuit breaker or, fuse disconnect, whatever it is behind that door right there. So this is plug and play. The only thing going between these 2 drives is transducer wiring and the Modbus connection. So that's how the lead lag works. So we went out there one time, we set it up, and we never heard from them again. So everything seems to be working well. This is another application that we're actually currently involved in. Within the next month, we'll be finishing it up. So this is an active one. So these are 2 ABB drives, and in the middle here, they're actually running a SCADA pack PLC, and there's a little like HMI there, like a 1-inch HMI, very tiny. So this screen broke, doesn't work anymore, but the lead lag function still works within the PLC. So the customer wants to rip all this out, and we could eliminate the PLC, we could eliminate the touchscreen and everything like that, and we're actually going to replace this with just 2 H100 pluses. So I'll probably update this and maybe put it on our, website or knowledge base or make some kind of article about it. But this whole panel here, this whole backplane is going to be replaced just by 2 VFDs. So it's going to be a lot simpler. It'll be easier to troubleshoot, hopefully less issues, because this was they've had some issues with this existing system. Some of the requirements they needed is a settable alternation timer. I mentioned we have that. Normally closed low suction input, system enable input to say the drive is available or not, and then also customize high and low feedback levels. So we could do all that with the H100 Plus, no issue. I mentioned earlier that we could also do some heavy duty applications. So since the H100 Plus has a heavy duty overload capability now. This is another local kind of Chicago suburb application we did with one of our distributors. And this is a bypass package. And on the left side here, there's actually an H100 Plus behind that door. And this was a 400 horsepower crusher application for, I think it was aggregate. So this is a crusher application. We set this up, I think, over the summer, and it's been working ever since. Never got a call back. So there is certain heavy duty applications we could apply the H100 Plus to as well. So if you guys have any questions, on sizing and, capabilities of H100 Plus, feel free to give us a call. Hopefully everybody has our 800 number and stuff. So speaking of like kind of support and sales tools and stuff like that, as far as marketing, we do have a new catalog. I'll bring up that in a second. We have an updated price sheet, which shows like the PL on the order codes, and it says the plus at the end of the model number. So it's not really different as far as ordering, but it does say plus. So it is, slightly different. I think you guys will see that. We're also adding a H100 Plus section to the lselectricamerica.com website. So it's not out yet, but it will be very soon. Internally, we're working on making sure we have everything ready. So we're going to have a video, we're going to have the catalog, we're going to have all the specifications, and that's going to replace the H100 section. We also have the latest manual under our download section on our website. So it's a quick manual, but I still think it's like 300 or 400 pages. So should have everything you need. It's also listed on our knowledge base, and we do have some existing knowledge base articles, which I'll show you on the next slide. And we're also working on a quick start guide. People like those little 2-page flyers for our other drives, so we're working on making one of those for the H100 Plus as well. We do run quarterly certified startup trainings, or CSTs as we call them. We just ran one last week, and we had about 10 people, and we talked about the H100 Plus the whole second day. So our training's been updated. So if you guys have any training requests or want to do a webinar, a Teams meeting, whatever, feel free to reach out to us, and we could always present this again or customize the training for you. As far as support, we've actually updated all of our H100 demos to H100 Plus. So if you have somebody in the field that needs help, we could help you out with that. As I mentioned, our knowledge base is currently being populated with H100 Plus content. So we have our quick manuals, we have, difference in sleep functions, backspin timers, differential level control, overcycling, all those functions that are new. We've been adding those to our knowledge base to kind of explain them better if anybody needs them. And then we're also getting spare parts in stock. So a lot of the internal hardware is the same as the H100. So we have spare parts, and anything that's going to be different as far as hardware, we're stocking that, right now as well. Okay. And I think, let's see. Yeah, this is just talking more about the HMIs, and I believe that was it. So the last thing before I open up for questions and see if anybody sent any messages for questions in the chat is this is the new catalog. So it's 24 pages. You should be able to find it on our website. If you have any issues, let me know. And I think I could send this all out as an email after. So H100 Plus, the game changer. And so you'll see right now we list the current offering we have, the 1 to 25 horse and the 1 to 800 horse. And if you scroll around enough, you'll see we also talk about the future updates. So I'm not going to read through this all because it's pretty much the same thing we just had in the PowerPoint presentation. But I think this is a really nice looking catalog. This is mentioning the voltage and horsepower expansion. So we're going to go up to the 125 horse, 230 volt. Then we're also going to have this 575 volt offering. This should look familiar. Existing features, new features that we all discuss. You guys are all experts on it. Lead lag control, flow monitoring, differential, all the things we discussed, in a nice format, looks pretty. So here's all the specifications. The new thing here is that you got, if I zoom in a little bit, you got your heavy duty, you got your normal duty ratings. Okay, so you got your horsepower, your kilowatts, your amperage. That is all right here. And then if you get towards the back, just like most of our catalogs, you're going to start seeing the mechanical drawings here, dimensions. And all these dimensions are the same as the H100. So the H100 accessories, flange kits, conduit kits, communication cards, it's all the same. It is a different keypad on the H100 Plus versus the H100 though. Okay. So that was all I had. Thank you guys.